Welcome to episode 26 of the Actual Astronomy Podcast. This one, we've had lots of warm nights and no wind, so that's pretty good. I'm Chris, and with me is
Shane, also enjoying the warm nights. Finally able to get some observing in.
Yeah, exactly. And so we're amateur astronomers, and we do this podcast because, well, this is what we like to do. We like to do astronomy. We like to talk about it, and we do a lot of this anyway. So this is almost exactly as per our regular conversations. And then I teach some astronomy courses, and so I sort of intermix a lot of the stuff that I do for those courses, which have been on pause, but which will start back up in August. So I'm pretty excited about that. So it's been nice and warm, eh?
Yeah, warm without wind, and we had a couple of evenings where the clouds broke and allowed for some observing, which was nice.
Yeah, and we're actually getting some darker skies creeping back in slowly but surely. I think this is going to be a wet week, but hopefully this will be the last round of rain for a while. Fingers crossed.
You know, and I think we said maybe in one of the previous podcasts, if there's going to be bad weather during the warmer observing months, let it be June, because the nights are too short anyway, and we don't do a lot of observing. So, hopefully we get into some dry observing weather as the days get shorter and the nights get longer.
Yeah, sounds good. So I think you said, like, just in one of our brief email exchanges or text messaging or something, that you had a couple hours in on Thursday night. Just wondering what you get up to that night.
Yeah. I had a really fun session on Thursday night. From about, 8:45 is when I started, and then I stayed out there for a couple of hours. I was using my 76 millimeter Takahashi, focal length or focal ratio of 7.5.
And this is a refractor.
The little refractor.
The new refractor, yeah.
Yeah. And I started off with the moon, which was, I don't know what it was that night, maybe 30%.
Yeah, something like that.
Yeah, something like that. And I spent a lot of time on, I think it's called Poseidonias.
Yeah, I mean, you could say it right or wrong to me. That's a name I don't ever recall hearing before.
Yeah. So what was really cool, and this is in general what I like to do with the moon, but what was really cool about this crater was, like, the crater itself was pretty much black because the way the angle of the sun didn't illuminate it, but the crater walls were very bright. But what was also interesting is a lot of these craters have a little mound in the middle. And so while the entire crater was basically black, the little mound in the middle was illuminated, and I was able to see that. And I like to look for those features on the moon, near that terminator, where there's a lot of darkness, but then you just see, like, the peak of something catching and reflecting some sunlight. I find that kind of neat. So I spent a lot of time looking at that.
Aren't those little mounds, like you refer to as little mounds? So it's a crater, and then in the middle there's this little mound. And my understanding is the action behind it is that during the early formation of the moon, like several billion years ago, I think it was like 3.9 billion years ago, during the late heavy bombardment or something like that, like there was an impact of, like, an asteroid, like a really large meteor that came in and smoked the moon, and then, like, because it was still liquid, or it liquefied the mantle, or the material that's there, it kind of like a rebound in the middle occurred. But aren't those little rebound things, aren't they like the size of Everest or something like that? Like, they're really, really tall mountains, aren't they? Or thousands of feet high anyway.
Yeah, they'd be pretty large. Features, I don't know what the limiting resolving power of a 76 millimeter telescope would be in terms of how large, or how small of a feature you can see on the moon. I don't know if they'd be as large as Everest, but certainly they'd be pretty huge. And,
yeah,
if I can see them with a little telescope.
Yeah.
So did that, and I was playing around with some old eyepieces again. I received it's a Huygens eyepiece made by Go2, so that's a Japanese company.
They
and
still
it was
make stuff, I think, eh?
Yeah, I don't think they make anything for astronomy anymore. I think they're more in the medical optics field, or maybe just general optics, like glasses and things. I'm not 100%
sure. One day.
But as far as I know, they don't make any telescope or astronomy stuff.
Oh, okay.
Yeah. But anyway, this Huygens that I got from, or that was made by them, is it's a 25 millimeter, but it's a module eyepiece with 4 components to it. and you can kind of unscrew it, remove a component, put it back together, and then it's a 12.5 millimeter eyepiece. So kind of neat, kind of adaptable. So I was playing around with that, as well as some Zeiss Huygens that I have, 25 millimeter and a 16 millimeter. And they are just on axis, like in the middle of the eyepiece. They really are fantastic. Now, there's a lot of detractors. The eye relief is kind of tight. The field of view is narrow. The edges are a little bit soft, but probably about 60 to 70% of that field of view is really, really nice. And the reason I'm mentioning that is these eyepieces are quite cheap if you find them. Now, they're a little hard to find because they're old, but if you do come across them, give them a try, because they they might impress you. They were quite sharp.
Cool.
Yeah. And there's some earth shine that night, which was kind of neat. So earth shine, like when the moon is in phases, the earth shine is, you'll notice kind of the outline of the moon, and you'll see the entire circle, and kind of the dark part of the moon is a little bit reflective, or it looks like there's almost like a dim light over there. And that's the light reflected from earth back to the moon that's causing that. So I was observing that a little bit. And then I looked at some double stars, the double up in Lyra, Alberio, and Polaris. It was a fun night.
Oh, cool. So how many double stars did you look at in total?
Well, so the double, that's two sets of two. That one had, I had to put some considerable power on that for that little telescope. I had to use a 5 millimeter eyepiece, which would get it just over 100 times magnification in order to split them. But it was a pretty easy split at that point. So I guess two sets of two there. And now Alberio is quite a famous double star. But the thing is, it's not an actual double star. It's an optical alignment. They're not actually in a system together. But what makes them fantastic to look at is one is like an orangey red star, and the other one is a blue star. So you really get that sense of the color contrast. And then our North Star, Polaris, has a very faint companion. Polaris itself, do you know what magnitude that is, Chris, offhand? Probably
I'm gonna
around,
go somewhere in 2 to 3.
yeah, something like that. And its companion is magnitude 11. So it's quite a difference in brightness between the two stars. And that's a fun one to look at.
Cool.
Yeah, yeah. How about you? I think you had some observing too.
Yeah, like not that much. Like I think you said you were up for a couple hours. I was out for about half an hour or so I guess it was on Friday evening. And
Okay.
then I was just looking at Jupiter and Saturn. Did you get a chance to look at Jupiter and Saturn when you were out?
Well, naked eye, I saw Jupiter. It just, with the buildings around my house, I don't have a great view of that horizon. And in order to see it, I probably would have had to stay up another hour for it to be decently positioned.
Yeah.
Yeah. So no,
That's
I didn't look at it with a telescope.
that's like the only advantage I have at my location is when the planets are up, I can see them, and I can see lots and lots of light pollution too.
Yeah.
So, but I have good horizons here. So yeah, I had a nice look at Jupiter through my 100 millimeter refractor, and this is basically just like the next size up version of your telescope.
Right.
And I was using that 5 millimeter Nikon NAV eyepiece or nav eyepiece that you loaned me.
How did that work?
I quite liked it. You loaned it to me. Mentioned that had some blackouts, which is basically it's when the eye is difficult to position over the big eye lens on the eyepiece. It could be difficult to obtain what's called the light cone coming to the eyepiece. And then when you're not able to quite get it in your eye lined up properly, it can black out. I did notice that a little bit. I really didn't think it was that bad. I mean, you could see it, but I definitely seen worse. Like I've definitely seen worse eyepieces for that. I'm not sure if it's any worse than the Pentax, to be honest. At least in that telescope. I know you said it can vary depending on the telescope and the configuration that you're using. So I don't know,
Yeah,
but
it's worked great in all my other telescopes. Just my 76, it wasn't. It was giving me some issues.
huh, yeah, that's found that a little bit strange because these telescopes are pretty similar. Mine's just slightly larger, and I think my focal ratio is better by or faster by zero point 0.1. So they're almost identical. Yours is just, like I said, just about an inch smaller. So
Mhm.
anyway, so yeah, so I quite liked it. The interesting thing, and it is sort of a funny thing with telescopes. You and I have noted this before, and that's that with the higher quality telescopes, you don't battle through the bad seeing as much. So they're able to kind of punch through bad seeing, and it's the way that the optical defects in the telescope work with the atmosphere, so that the worse the atmosphere and the worse the optical defects are in any given instrument, they like compound, right? I think you and I remember we were comparing some telescopes on Saturn once before a number of years ago. Do you remember that?
Yeah, yeah.
And you can notice even pretty subtle differences in the optics. So I was really surprised because the seeing on Friday. I don't know. Did you get out on Friday?
No, I took your little 80 millimeter out just for a quick star test, but it was kind of cloudy in my end of the city, so I just wasn't motivated to drag out a telescope because of the cloud.
Yeah, well, I mean, yeah, it was kind of funny that there was cloud over most of the sky, but we live in opposite ends of the city, and I don't know how far apart we are, maybe 15 or 20 kilometers or something like that. But yeah, like the sort of south easterly quadrant of my sky was totally clear, but the seeing was very poor. So you could see kind of like any stars, or really kind of there was flashing, and it was very unsteady. But what was neat on Jupiter is that with that 5 millimeter, anyway, and that's given 150 power in the 100 millimeter telescope, which is a little high, I think, on Jupiter, especially in that kind of seeing condition. But I could see all kinds of like little dots and detail on Jupiter, kind of behind the seeing, right?
Oh, wow.
It
That's
was,
very interesting. And, you mentioned like the high quality telescope optics can kind of help deal with seeing. I've noticed that too with eyepieces. There's times where I would have just chalked up kind of a marginal view to bad seeing.
yeah,
And then I put in like a high contrast, high quality orthoscopic eyepiece. And all of a sudden it's like the seeing got better. And then I go back to say, whatever eyepiece I was using previously, and the seeing in quotes gets worse.
yeah.
And that's just the quality of, or that's just good optics helping you kind of like you say, punch through it, or maybe even just bad seeing's misdiagnosed sometimes as just, optics not performing as well as they could if they were better.
Yeah, it is surprising. Like I think the eyepiece that we've referenced for this kind of purpose before is that Pentax 5.1 XO, and it's remarkable to go from like a really high quality multi-element eyepiece, and you think, oh, the seeing's pretty good, or I feel like I could see lots of detail, but it's not quite as steady as you'd like it, and then you put that in, and then it's remarkably improved like magic, right? And you're like, wait a second, and it's just any kind of additional like airspace, any kind of fuzz that you get from, you know, even the best multi coatings, but the more of those that you have, the more impactful that's going to be on the image. Like it's surprising how you notice, what really one might think should be, very subtle differences at the eyepiece when you're trying to see sort of at the edge of what's possible to see through a telescope. You really can see quite a bit more when you get the number of elements down and you get the optical quality fairly high.
Yeah, absolutely. There is some truth to the simple glass approach, or getting eyepieces that have as few elements as possible. Now, but there are some exceptions to that, like that 5.1 Pentax XO that we've referenced. It's not like an overly simplistic eyepiece. Like there's five or
No,
six elements, I think, in
five.
there.
Yeah, I think there's five, but there might be
Five.
six.
Yeah, and it's just extremely well done. So
Yeah.
uh, there's always exceptions, I guess, to every rule, and the EXO is certainly one of them.
Yeah. Well, I think it's like the Goldilocks, right? It's got the lowest number with the highest quality. I think that's what it's threading, right? To
Yeah,
to,
yeah,
to get like this beautiful field in an eyepiece that's unobtainable.
yeah.
Yeah, I didn't compare it. Like I'm still waiting on getting a mount, so I'm a bit hobbled by just using the LDAS mounts that I have, which aren't working exactly as I'd like them to work with this setup. But I did get to try out the Prima Lucha rings.
Oh yeah. Okay. How are those?
Those are pretty cool. I gotta admit, those work really well.
Good. Good.
They're really, really nice. The only thing that I noticed is that, and it's not a fault with the rings. Um, it's just that I'm mounting them on a Losmandy Vixen dovetail. Now, let me explain this, because this gets, even for amateur astronomers that know a lot of this stuff, it gets confusing. So Losmandy and Vixen are two brand names. So Losmandy makes, pretty much they just make mounts, I think, and
Yeah.
Vixen makes mounts and all kinds of stuff. But these are each also, I guess, what do you call it, like a format or something for the bar that attaches the telescope rings and thus the telescope to the mount itself. So there's a Losmandy format and a Vixen format, and they don't look that different. The Losmandy one is a little bit wider than the Vixen, basically. But what these are is they kind of just sort of slide in. So you have like an opening, and then it's like a bit of a grab claw ish, like depending on your exact mount, and then it grabs on. You just turn a screw and it grabs on to this plate, and the plate has holes in it, and the holes are where you fix the rings, and the telescope sits in the rings. But the little Losmandy Vixen plate that I have um, has sort of a limited number of holes in it, so I only get to use two screws to mount the Prima Lucha rings to the plate. And yeah, I'm not so keen on that. I kind of would like to be using two screws per ring in a 100 millimeter telescope. 80 millimeters or less, I think it'd be fine. And this isn't a real heavy telescope. It starts to get a little bit on the big side, I think, for just using one screw. So I don't know. I might go and get a Prima Lucha rail, dovetail rail, and see, or try to figure out another way to mount this off. It's not a big deal, but anyhow. So, but that AZGTI mount, I talked to Stefan at I always have to think about that, because it used to be Lila Nature and now it's the Astronomy Plus. And anyway, so he was having a little bit of trouble tracking this stuff down. I guess the Skywatcher mounts, anyway, the AZGTI mounts come through Celestron in the States or something like that. So anyway, so he was working on tracking mine down, and he said should hopefully be here sometime in July. So that's sort of an exciting thing to look forward to.
Yeah. Yeah. That'll be great. Hopefully you get it in time for, well,
Yeah, any
planet
kind of
season is
dark.
starting.
Yeah, yeah, and
You definitely want it.
any kind of planetary observing will definitely benefit by having this little tracking mount. So yeah, I'm pretty excited about that. But you mentioned that you were out briefly on Friday testing out that 80 millimeter telescope. So I had purchased basically $100 telescope and had made some modification to it. I put a new focuser on it, and then it had these horrible pinch optics, and I'd finangled you into kind of working, maybe working some magic there to get the optics working out a little bit better, and just wondering how things ended up for you on that.
Yeah, so Friday night I had some spare time and thought I'd begin surgery on your little 80 millimeter telescope. Um, so I had to remove the dew shield. So a lot of refractors have a like an attachment at the end of the tube that extends past the lens, and its purpose is just to keep dew from forming on the lens. So I removed that first, and then that exposed the lens cell. and it was attached to the telescope tube by just 3 common screws. So I undid those screws, and then I was able to remove the entire lens cell. So the lens cell is like basically this plastic holder for the glass lens. So it came apart actually really easily. I was a little concerned because sometimes those things are, a little sticky or just really tightly put together. But yeah, this one came apart pretty nice.
Quick question. How difficult was it to get the dew shield off?
Uh, Not bad at all. What I did was I just kind of gave it a couple wraps with my knuckle. And then I just started like kind of at the top, pushing it like one way and then the other way, and then just sort of going around in a clockwise direction, just push, pull sort of thing to
Okay.
slowly loosen it off. And I don't know if they used glue or anything like that, but after I did pretty much a full rotation, it was loose enough that I was able to pull it off, but it still has enough friction that I don't think you'll have any worry of it just falling off, like even in transit or anything like that.
Yeah,
Um,
so I thought that maybe they had glued that one on because to me anyway, it seemed so tight, and I hadn't thought of doing. I'm not as mechanically inclined as you. That's no secret. Um, yeah, I hadn't thought about taking that kind of approach. That's pretty smart. I was just trying to like use like brute force unidirectional, and that was not working. So at that point, I was kind of like felt kind of like the caveman trying to open up the beer bottle kind of thing, right? You're not done until it's just smashed on the ground, right? And you're jumping up and down. But yeah, so I appreciate that. Well, that's awesome. That's awesome.
yeah. So once I got the lens cell out, the next step was to free the glass, get the glass lenses out of the lens cell, because with pinched optics, well, maybe let me just back up. There's a retaining ring that will always be in place in some fashion to hold those glass lenses in the cell. Now, sometimes that retaining ring can be tightened too much and causes these pinched optics or deformed optics. Loosening that corrects it. So on this particular, what is it? A Mead Adventurer?
Yeah, it's a Mead Adventure Scope or Mead Adventurer, and this is essentially a new edition of what's lovingly referred to as the ST80. So there's been these 80 millimeter f5 telescopes produced since I don't know what, like the 80s or something. And the really neat part about them is that they are pretty inexpensive. They always have been. They seem even less expensive now than they used to be. This one with a bunch of stuff came to around $129 or something like that. The telescope itself is like 99 bucks. And for that price, you're really getting a pretty decent quality multi-coated, for the most part, as good as you're going to get for $99 anyway, optic that works really well at low power. So it's basically just a low power telescope.
Low power and wide field. Like you can
Yeah.
get some outstandingly wide fields with that thing. It's incredible. So anyway, the retaining ring on this particular telescope is just like a plastic threaded ring on the front end of the lens cell. So it easily unscrewed. And then this particular refractor is a doublet. So that means there's 2 glass lenses in that lens cell. So I plop them out. And then another thing that is recommended, I guess, for these telescopes online is the edge of the glass or the edge of the lens is not blackened. So they just grind it in a circle and then put it in the lens cell, and that's it. And I sent you a photograph of kind of a partially blackened. So what I did is I took a Sharpie marker to the edge of the lens and I blackened it to prevent some stray reflections bouncing off of that ground edge. And it's incredible to see the difference. Like when you look through the glass without any blackening added, the kind of rough grinding that's left behind is white almost, which
Yeah.
is obviously quite reflective.
Yeah.
And in a telescope, you don't want any light bouncing around. If you do, it'll just take away from the crispness and the contrast that you would be able to see through that telescope. And just taking a Sharpie and essentially coloring that ground edge of the lens was night and day, like literally and kind of pun intended. It
Yeah.
was quite incredible the difference it made.
Yeah.
So
Huh.
so anyway, I blackened the edge on both lenses, put them back into the cell. I did clean them prior to that too, just with some Zeiss lens wipes to get.
Oh, wow. Very nice.
Yeah, I pulled out no stops here. So
Wow.
put it back together. And when I did the retaining ring, I tightened it. You can kind of feel when it makes contact with the glass because there's suddenly some resistance as you're tightening. And I
Yeah.
basically left it there. As soon as it touched the glass, that was it.
Okay.
It's very easy now to either increase that or decrease that because that
Yeah.
dew shield will come off quite easily. And then
Okay.
you don't even have to remove the lens cell. That retaining ring is accessible as soon as the dew shield comes off.
Yeah.
Um, so put it all back together. Took it out under the night sky. And I should say that before I did any work, I did take the telescope out and I sent you a text after I did it because I wanted to see kind of the before and after, effects.
Yes. And
And
I'm really glad that you did that because, I mean, part of this was that, well, the telescope was so compromised that, I was probably just looking at just turning it around and just selling it like for $50. Or I shouldn't say that because I put this expensive focuser on it. So probably like $150 online to recoup the cost of the focuser. And then maybe somebody else who's handier than me would take a crack at it. So, but as well, I don't think you'd seen like a really good example of really bad optics. And I was like,
yeah,
ooh, this would be, I think you've been fairly lucky in your astronomical purchases. I've had a few stinkers over the years, and then this really took the cake, So
yeah, you're right. I have been pretty fortunate. I've bought a number of telescopes, some new, some used, and they've all really had pretty good optics. So anyway, I did the star test before and after, and a
so
star
what's a
test.
star test? Okay, okay.
Yeah,
I was gonna say, all right, let's tell people because I don't
yeah.
think, and
I don't
there's a
think we've
really
talked.
good book by a guy named Suter on star testing astronomical telescopes. I think that's what it's called. If people want the
Yes,
reference, do you have a copy of that?
I do. And I think
Okay,
if,
yeah,
if you're going to be, and we should have talked about this maybe last week during our book talk. I think if you're going to own a telescope and, I guess if you just buy one in your whole life and that's it, I guess you don't need this book. But if you're
no.
going to, probably buy and sell telescopes, and most amateur astronomers do, I think you got to have this book because it really helps you understand how to evaluate telescope optics.
And
And
this
that's
is
important.
fun, and this is very fun.
Yeah.
Like I bought that book. When I was living in Ontario. I bought that book and I read it cover to cover. It's one of those. It's sort of like a magical thing for me anyway, because just the way my mind works. So I read it. I enjoyed the read, but I didn't really understand that much of it. And so what I did is that summer I took it with me, and in Ontario there's a lot of observers and there's a lot of different telescopes, and I was able to go to some star parties and some informal. Like we had a lot of informal astronomical gatherings where we'd have like maybe up to 30 people at an observing session, which is a lot of fun. It's almost like a little star party in itself. And I kind of kept the book in my car, and I would actually go and star test people's telescopes for them to get a really good feel for what's out there and everything. And it was amazing. There was one person. This is a little bit of a tangent. Do you mind me going on a bit of a tangent?
Oh, go for it. Yeah, do it.
So there was one individual, and he had a telescope that I always wanted to look through, I think it's called a Stellar View 80/9. I don't know if you've ever heard of this.
No.
And I'm not sure if they're an achromat or an apochromat, but if they're an achromat, they're long enough and the glass is good enough that you basically don't get any color, and they're highly reputed. But when I star tested his telescope, it had the strangest star test. This is a little refractor, an 80 millimeter, but I think it's like an f9. Okay,
Okay.
and it has good glass, so it's either an apochromat or it's an achromat that's almost completely color corrected, and it looked like it had a 4-vein spider in it.
Wow.
And I just went. He said, "What do you think?" And I said, "Do you look? Do you really want to know? I mean, if you're enjoying the telescope, then Bob's your uncle, right?" Like I didn't want to make the person feel bad. He was a really nice guy, and I knew him. And he said, no, like I want to know. And I said, well, I said, I'll show you. There's a strange optical aberration here. I'm not sure what it is. It's not in this book. I've never seen it before, and I had tested quite a few scopes at that point. And he looked into, and he could see it, and he said he wasn't really sure. And for the most part, and the telescope did give good images, like unless you were taking it out of focus, and that's how you do these star tests. You take them a little bit out of focus. You focus a little bit out on a bright star, and then you focus through that star, and the star will go pretty close to a pinpoint or a very small round circle. And then on the other side, what you'll see is a series of rings, and these rings, more or less, they kind of look like if you sliced open an onion. Kind of think is probably the best way to put it. And sometimes you'll see no color once it's in focus. You might see a little bit color out of focus in a refractor, and that's all my refractors work. I don't have refractors that are color free out of focus, but this gentleman's telescope had this weird X right through it. So it worked out really well because he called the manufacturer, which was Stellarvue, and it's a reputable company down in the States. A lot of people buy their equipment, and apparently Stellarvue does something to some of their telescopes, or at least they did. And this is 15 years ago now, where they had put like a second set of screws in it to make sure that the optic wouldn't get damaged during transit. And they would include a piece of paper that instructed people to you just took like an Allen key or something like that, and you just backed off these screws, or maybe you could take them out or something. I don't know exactly the process, but anyway, this individual contacted Stellarvue, and then they were able to get it resolved really quick. Like it's a very, very simple process. So that right there paid for the book, because here this person had they're not a crazy expensive telescope, but still it's a telescope they paid their good money for, and it just wasn't working as the manufacturer had designed. And so we were able to kind of figure out there was something wrong there and get that resolved.
That's awesome. Yeah.
Yeah.
Great reason for it. And another thing that book taught me that I use just about every time I look through a telescope, and that's how to tell if the telescope is thermally acclimated to the outside temperature.
Yeah.
Because you do have to let the telescope reach the same temperature as the outdoor air, and if you don't, there's a risk that there's going to be like air currents within the telescope's tube that kind of distort the view. And just doing a simple star test will tell you right away whether or not that telescope is kind of warm, or if it's nicely acclimated.
Yeah.
That's quite helpful too.
Yeah.
But anyway, so thanks for explaining how to do the star test, or what to look for.
Yeah.
You should probably use at least, what would you say, around 100 times magnification to do an accurate star test. Is that fair?
Yeah, you can use that high power. It's not necessary to go. Really, what you want to do is just use enough power that's going to give you those circles. You're going to use like medium power, really, whatever that is in your telescope. So, for example, for my 100 millimeter, you can probably use anything from 50 power on up. Should be fine. And most telescopes should be reasonably fine at that. But that book explains exactly how to do it. So don't take sort of my off the cuff, unprepared remarks for doing it. That book is well worth it. And I mean, these are not expensive books, and I think you can find most of the information online. If you Google Suitor star testing, I think much of the information has been put out for free. And man, I feel like that book might cost $40. And considering, if people are spending at least $400 on a telescope is sort of the entry level point, then spending a tenth of that to make sure it's working properly is good insurance. Otherwise, like how would you know, right? Like when I first had telescopes, I didn't know, and I had some real stinkers. And that really made me feel bad. I guess I shouldn't, and that's why I try to be pretty careful. Like I will almost always star test people's telescopes, but I seldom tell them I'm doing it. Unless I'm doing something in particular, or they want it star test, or they think there's something wrong with it, because honestly, for the most part, a lot of people don't care, or they're just happy with it the way it works, and that's great. If they're happy with it the way it works and it's working and making them happy, then who am I to kind of come in and say, oh no, I always think of, I don't know why I'm going on tangents today. I always think of the person who took my astronomy class, and we do these sessions, we go out with binoculars, and you know what that's like. We take binoculars out and we go up. Now you and I own all kinds of expensive binoculars and whatever, but this is what we like to do. But most people don't own expensive binoculars. They're just going to own a pretty inexpensive pair of low-end binoculars when they show up at my class, right? Or any class, if you're using binoculars for anything. And this one individual, they showed up with these. They were actually really decent, inexpensive binoculars from about the 80s or something that they had picked up at a yard sale for, who knows, $10, say. Perfectly good, perfectly serviceable. They were aligned. That's the main thing. You're going to talk about alignment here in a second. And they said, yeah, what do you think of these? I said, hey, yeah, these are great. This is all you need. My only comment was if they needed to wear glasses, these, would reduce the field. But other than that, they didn't, they're perfectly fine. And they said, oh, that's a relief, because they had taken some other sort of course that wasn't astronomy. And the instructor told them that their binoculars were garbage.
Oh,
I always felt like so bad for that individual. I'm like, you know what? Like the person's probably not going to go out and drop like, a lot of money on binoculars. Some people will, and that's great. But, this person was just like taking like all these interest courses. And anyway, but like, here we are 5 minutes later, and the person hunted down the Andromeda Galaxy for the first time by themselves, and was able to view it. And whether or not they were using a $10 garage sale binocular, or like, a pair that I might have paid like $120 or $150 for, like an expensive pair. What's the difference? They're, the view is actually pretty similar, more similar than different, right? What's
absolutely. Yeah. You start to split hairs.
You start to split hairs, and again, like, although we're buying some expensive gear or whatever, but this is what we like to do, and we're free to do that. But you don't necessarily have to buy the most expensive equipment, and and this little telescope kind of shows that. But when you are not spending as much money, if you are spending the money, that it should work out of the gate. When you take that out, you look at a star, you should be pretty impressed with what you're seeing for a star test. It should look like the how things should look like version of the images in the Suter book. But when you're spending $99 on the absolute cheapest serviceable telescope available, it's going to have some shortcomings. You're going to talk about some of these shortcomings now, and I will shut up.
Yes, it certainly did not look like the textbook image that you would hope to see. So I found a bright star. I put in a 5mm eyepiece that got me a little over 100 times, and I defocused it both directions and really had the same result. Now, what you want is you want to see that bright star. It kind of looks like a bullseye, where you have a star in the middle, and then you're going to have rings around it. And you want all of those rings to be circular, and you want them all to be somewhat evenly spaced apart. Your little 80mm, as you know, was not that. That central star was not central. It was kind of way off on the rings. And the rings themselves were almost kind of teardropish, right? And the teardrop certainly is the sign of pinched optics. If you look in Suter's book, that's the image that he shows.
What I call it?
What's that?
Well, it's funny, I don't know why. We're just chatting today, and it's rainy weather. This is gonna be like the longest podcast ever. But so I was having some asthma the past couple of weeks, and they always say, like, take the medication your doctor gives you. Of course, I don't like taking medication for anything. I don't like taking drugs or anything like that either. It's fine, just who I am. But I just was resisting taking my medication. So finally I take it. Of course, I feel better right away. And then right before this podcast, I ate all these jalapeno nacho chips. But I always say that the badly pinched optics, so you say it looks kind of like a teardrop. I think it looks more like a Dorito potato chip. Like if things have gone really bad in your optical system. Yeah, that's what it can look like.
Yeah. So that was the before star test, and then the after star test. I feel like the rings, like that teardrop or Dorito shape, has kind of disappeared. Like I think loosening that retainer ring certainly helped, but that central star was not central still. Like it was kind of off. I'd say to the top left, if I remember correctly.
Yeah.
Which is a sign of miscollimated optics, I think. Now, collimation means perfect alignment in your optical system, and that goes for any telescope, whether it's mirrors or lenses. So if it's not collimated, that means that that light that's coming through the telescope isn't going straight through the way it should. And sometimes with like on Dobsonians or Newtonians, they're very easy to collimate. They're made to collimate. There's some screws that you adjust on the primary mirror to align everything and change the angle of the mirror. And it's pretty simple to do. But on refractors and like even Cassegrains, it can be a lot more challenging. In fact, some refractors you really can't collimate. In order to do so, you need to have collimation screws in the lens cell, and not every refractor comes with those.
Right.
In fact, most don't,
Yeah.
in my experience. And the little 80 millimeter is another example of that. So I think one thing that could try, and I don't know if it would result in anything, is so there's the two lenses that make up the telescope, because it's a doublet, is just slowly rotating one of those lenses, and maybe that brings it into collimation. Hard to say. I
Yeah,
don't know.
that could do it. The one thing that I'm thinking of, and that could definitely help. So here's what I witnessed when I pulled the first focuser off. The tube is not round. Like it was
Oh,
really, yeah, the tube is almost like teardrop shaped. Like it was out of round. So I don't know if that could be doing it too. I mean, I don't know. I don't know how much you want to futz around with this, Shane. I mean, I really appreciate this, but if you want, you can bore it for a long time. It's great. But if you pull that focuser up, which is pretty easy, just back those screws. You just take the
yeah.
screws out. There's 2 or 3 screws, and then you just slide it out. It's pretty easy. Even I could do it. But yeah, you'll see that tube is really out of round. So I was a little bit thinking that
Well, and
that's it.
anytime you put a focuser on a telescope, that you also risk, throwing collimation out a little
There's
bit.
that, yeah.
Yeah, because like again, the high-end telescope makers, they'll add little shims on the edge of the focuser just to get it perfectly aligned in the telescope tube.
Yeah.
So there's quite a few points, I guess, in that optical train where the collimation error could exist, and probably
Yeah.
pretty hard to track down.
Yeah. Anyway, yeah, it's great though that you're able to do the main work, and if you want to keep it for a little while and play around with it, I mean, it'd be nice. So that telescope, one of the reasons why I bought it is for observing with you, because you have the perfect eyepiece to mate with it, which is the Nagler 31.
Yeah, great wide field eyepiece that is you can use it in fast telescopes like that little 80 millimeter, and still, theoretically you should have pretty sharp stars all the way through the field.
Well, definitely better now.
Yeah, I think so. I'm curious to actually see what it looks like under a darker sky with a lot of stars, because the second test Friday night, like I mentioned earlier, was kind of cloudy and I really wasn't able to see too much up there.
Yeah. Cool. All right. Well, yeah. Thanks so much. Thanks so much for doing that. I do really do appreciate it. And yeah, I have another one coming. I have another 80 millimeter coming. So
Yeah, it'll be neat to compare the two. Hopefully that one is a little bit better.
Yeah. We'll see what we can do with it. But so maybe I should say, like, why am I getting these? I say we because like Shane's going to use one as well. The method to my madness is this, and that is that there are times where we don't wish to be taken out our expensive telescopes because of some of the adverse conditions that we have to do astronomy in. So when and this happens at least once every 2 years, where we have very compromised conditions, and we're doing public outreach and education. So we have a lot of people from the public there, which we're trying to show them stuff through telescopes. But we've had a few different scenarios. We've had scenarios where there's been a lot of smoke from like a campfire or something even. We've had situations where there's been like very small but light rain showers moving in, which aren't a big deal for an inexpensive telescope. If you drop some lens, you just grab one of Shane's ice wipes and you wipe it off. It's not really a big deal. You don't really want to be doing that as much with the more expensive gear. So my thinking to get these inexpensive 80 millimeter telescopes and getting them working well enough is that when we get in those situations, we can still show people the stars and planets. Like, they work pretty well. And for the most part, like, a person who's never looked through a telescope before is going to going to really enjoy the views, and we're going to give them the full sky show that we're there to do. And it's only a sort of once in a while kind of thing, just when we get those adverse conditions. Like I was thinking last year, like I felt bad. We had those little like rain showers that were coming through. Like we'd get a rain shower and then it would clear. I don't know if you remember that or not.
Yeah, I do.
And then you just couldn't set up. Like even some of our friends who were there setting up as well with with their lesser expensive telescopes didn't want to have them out in those conditions. There was a lot of dust, and then it would rain, and the dust would stick. Really not great. So the expensive scope stayed in. But my thinking is, and they mount up to all the mounts that we have anyway. So if I get a couple of these, I mean, we can maybe even throw them in like Mike's camper or something like that for the summer, and then if we ever need them, like there they are, right? It's no big deal, to have them kicking around.
Yeah, it's a great idea. I like it.
Yeah. Anyway, I just thought it'd be interesting. And the second one is even cheaper. So the first one was, I called it a $99 telescope, and I'm thinking like $99 American. I think that's what it was. But this one was $30 Canadian. So I'm not sure if I'll get it or not. Like I'm having trouble getting the mount. So I don't know if they're gonna send it along or not. I don't know what the story is. So anyway, we'll see.
Fingers crossed.
Yeah, fingers crossed. So anything else to add, Shane? This is like our longest one. Yeah, last week they were shorter. This week, I guess I'm bored because it's been so rainy today. So
no, that's good. Thanks, Chris.
All right. And do you want to mention like how people can stay in touch with us or anything like that?
Yeah, so we are on, so the podcasts are hosted on Podbean. So if you have an account there, you can message us through that, app. But we're also on Twitter. So if you look up at Actual Astronomy, that's us. And we tweet out notifications for every new episode. But feel free to send us messages or, comments or anything like that.
Sounds good. All right. Well, if there's not anything else, then we'll end it there. And we thank everybody for listening. Really appreciate it. We're having a lot of fun doing this. Talk to you soon.
Thanks.